My friends, it just keeps happening. There's another Linux vulnerability we're going to talk about today. It's very similar to the last one that was like, what, a week ago? Copy fail. This new one is called Dirty Frag. What a ridiculous name, but this vulnerability is no joke. So I was at the movie theater tonight when I found this out, and I am just, again, so thankful that I picked the right time to quit my job and be unemployed, because I would not want to have to go through and fix all this across a whole bunch of machines. But yeah, I'm at the movie theater. I'm enjoying some Mortal Kombat 2. Great movie, by the way. Go see it if you haven't already. And I'm looking through this like GitHub repository for this exploit, and I'm like, oh man, this is going to be bad. Just like copy fail was bad, this one's going to be bad. And it seems like there's no fix in place. There are ways to fix it, but like there's no kernel patch available, at least as of right now. I am recording this, what is it, May 7th, right before May 8th. So that's why I'm here. And I figure today, just like my previous video with copy fail, we will go through it and we'll fix it on my home network. I'll test some machines, we'll make sure everything works, and I will show you how I will roll out a fix for this. I won't dive into the specifics of the exploit. Again, it's a little bit above my pay grade. I don't fully know, and I know other people out there will make way better videos explaining it. It looks like when I delve into it a little bit, it's kind of a similar mechanism to how copy fail worked. I know it involves the splice syscall. It's like Linux specific. So yeah, there's some interesting stuff there, but I'm going to show you how I'm going to fix it across my whole suite of systems and how we're going to test for it and things like that. So yeah, let's jump in. So here we go. I got the repository for the exploit that you can run yourself up here. I'll link to it in the description, and there's a whole bunch of stuff. You can see a nice little video of a whole bunch of systems being owned. It's pretty simple. So to exploit it, they give you this one-line special. All they do is clone the repo and then compile the program. We'll do it ourselves. There's really not much going on there. And they have a whole list of affected systems. I don't see Void Linux on here, but spoiler alert, it's going to be affected. So here's the mitigation. They have a way of fixing it. I will break down exactly what this does. They've made it all one command, which is super nice. But again, like I said, I'll break down exactly how this works. So yeah, I like this little line in the README right here. Yeah, I know, another branded dirty series. However, this vulnerability is a descendant of Dirty Pipe, and it is a bug class that, quote, dirties the frag member of this struct sk_buff. So this name is the most appropriate, Dirty Frag. So there you go. So simple enough. I'm going to go here. I'm going to copy this to my clipboard, and I'm going to move over to the terminal, and we can actually go ahead and clone this source code. So already I'm SSH into my Linux machine. Again, this is a virtual machine that's running Void Linux. Here, I'll give you guys neofetch. I always like that. Command looks beautiful. So let's go into my dev directory. That's where I do my development work. A little bit confusing. Some people are like, hey, shouldn't that be devices? Yeah, well, I've just been using this for so long. That's what I do. So git clone this. And there we go. It pulled it down. So this is slightly different than the Python version. Obviously, this one's in C and not in Python. It's a lot longer. So it's a C program, but let's take a look at this. If we jump all the way to the bottom of the file, you can see, look at this, 1951. There's almost 2,000 lines of C. There's a lot of cool options packed into this. You can even see it does some really, really basic command line parsing. It even checks for environmental variables. So we're going to make use of some of these flags that it looks for. But yeah, I'll show you how it works because it's surprisingly simple and surprisingly terrifying. So let's compile exp.c and we'll call it exp for exploit. So there we go. Now it's compiled. We have an executable file. Let's go ahead and run it. Takes a little bit to run. It's not instant like the previous copy fail one, but when it finishes running, something really interesting will happen. That's the interesting part. You ready for this? We have a root shell. There we go. Another user land program that's able to create a root shell. So yeah, that's fun. If we do this, and then we can stat, whatever we call that, you can see that we are root, and we have root privileges on this machine. So yeah, just not great, guys. So I have a bunch of machines on my network that I want to test. I think I had like 9 machines from the last time we did this. I think for this video, what I'm going to do is I'm going to come up with the mitigation, the fix for this specific machine. And once we have that working, then I will show you how to test all the other machines. So I'll get it working on one machine. We'll make sure it does exactly what we want. Once we have that known, then we'll fire that off to the rest of the like 8 machines on the fleet. And I'll show you guys how we can do that. I have some tooling for that. I'm going to show you how to do a little bit of it manually, because if you're following along, you might not have this tooling. If you're a sysadmin on systems that like you normally don't work on, or you're not able to copy your tooling over, I'm going to show you how to do it just from the shell, because I think it'll be really cool to dive into. So let's back out of this, Control D to exit, and let's figure out how to actually mitigate this, because we know the system is broken. If we go back up to the website here, we can see that their mitigation is here. Now, it's a one-liner, but there's a lot of stuff going on here. So I'm going to copy and paste this. We're going to pull it into the terminal here, and we're going to break down what it does, okay? So let's make a new script here. We'll call it fix. This will just apply the fix, and we'll paste that in there. Now, as you can see, it calls shell minus C, which runs that whole thing through shell. So let's put a shebang on here because technically speaking, this is a valid bash script. This is also a valid POSIX shell script, but we're going to use bash just because I'm more comfortable with it. And if it works in a POSIX shell, it should work in bash. So we can save that. We can chmod +x fix. If we run that, it should fix it for us. But let's figure out what's going on here, okay? Because shell minus C basically says run this whole string like a command. That means we can get rid of shell minus C, and we can get rid of that final quote at the end. So here is what's being run. It's a little bit easier to understand, but still kind of gnarly. If we search for a semicolon, we can see that there's 2 semicolons there, so we can turn those into new lines. Because a semicolon just means like a new command instead of putting a new line. It looks like this. So the true at the end is just to make sure you have a healthy exit status code. There's no reason to run that, so let's get rid of that. This hides error messages because you're removing kernel modules. You can actually take a look at this. This is I think it's a Linux thing specifically. Yeah, rmmod, simple program to remove a module from the Linux kernel. Yeah, it's got Linux right in the name right there. So yeah, this is to remove a module. So you can see that they're throwing away error messages. The reason being is maybe only one of these modules is loaded and that's all that is needed. So in this case, we just disable all 3 of them. So say one's loaded, we disable that one, but then 2 are unloaded. We'll still get errors. This just hides them. I don't care about that. I don't want to hide errors. Let's get rid of that. Let's just make sure we see all of the errors. And then we printf this line with a new line, this line with a new line, and this line with a new line into this file. Now, the beautiful thing is because we're in bash, we can do some kind of magic here. So where there's a new line here, instead, what I'll do is I'll close that quote and then open up a new line. And then where there's a new line here, I'll close that quote and then open up a new one here. And then we have this. So what we can do, we're in bash again, we can group these commands together. Yes, this is valid syntax. We can group all those commands together and redirect it all to this file. This is totally fine. It works just the same. There's nothing wrong with this. I think it's just a little bit easier to read. In fact, if you're looking at this, we're just printing and then emitting a new line ourselves. We can get rid of the new line here. And then instead of using printf, we could use echo, which just prints to the screen and appends the new line for us. And the beautiful thing about grouping commands like this is we could just run commands here. I could just put like ls or whoami if I wanted to, and it would just go in that file. We don't want that, but I'm just showing you how it works. So what we can do is one last thing to clean this up is we don't need to run 3 different commands here. There's another way we could do this. We could just use a here doc. So we could just cat read until EOF and then write that to etsy modprobe.d dirtyfrag.conf. And there you go. Now whatever we put here until EOF will get written into that file. So we can just move all this down here, get rid of the echoes and the single quotes, the apostrophes or whatever. And there we go. This looks a lot better. So we will cat, we will redirect it into that file, and we will just write this data directly into the file. So it's the same script. I just kind of unminified it and hopefully made it make sense. Etsy modprobe.d dirtyfrag.conf. That looks fine to me. So let's go ahead and actually run this fix. If we run it on its own, we'll get errors because I'm not running as root. If we wanted to run as root, we could just use the exploit. We're not going to do that. Is that stupid? I would just run sudo./fix. Should we use the exploit to patch itself? There's something like poetic about that, isn't there? I think there is. Let's go ahead and run the exploit. This is really stupid. Okay, now that we've ran the exploit, we can go ahead and run ./fix. And there we go. We got some rmmod errors. As you can see, there was an error for these two, ESP6 and RxRPC. Let's get out of that root shell. Let's go look at the fix again. If I show the source code for fix, you can see that it was not able to load this. It was not able to unload this. So ESP4 must have been loaded. This was the one that worked, and then these two threw the error. So that's what happened there. If this all works successfully, we should have etsy modprobe.d dirtyfrag.conf should be there. And there we go. That looks good to me. That's awesome. So we have that file ready to go. If we rerun the exploit, we get a root shell. We get a root shell pretty fast that time. That's pretty cool. So let's go ahead now and just reboot the machine. And this is a virtual machine. It should reboot pretty quickly. All right, we are back in the machine, running uptime. We've been up for 0 minutes. That's awesome. Let's go back in the dirty frag directory and let's run the exploit. Look at that. It fails immediately. How awesome is that? We even have an error exit code. I love this code. It's written very nicely. I'm so happy for it. So it fails now. In fact, I should have shown this earlier. I'll show this before. There are some flags it takes. Verbose is one of them. So if you run this, you can actually see exactly what it's trying, which is really cool. Not so much detail that's helpful for me, because again, I don't know what RX, RPC, what this kind of socket stuff going on is. I don't fully understand this exploit. I'm coming at it like a sysadmin who's tasked with fixing it. That's cool, but there is another flag that I noticed in the source code itself, which is super interesting, because you see there's a lot of flags here, but there was an extra one. So if I search for open double quote hyphen hyphen, this is kind of how I found them. There was another one here, corrupt only. And this is very like nestled in the code, which I was a little bit surprised of. But we have this corrupt only flag that we can use. And this is cool because it won't actually start the root shell. So what happens if I run this with -- corrupt only? You can see that, well, we get the same thing. We get the error message. But when you run it on a machine that's exploitable, it will just try to corrupt it and it will return success, but it won't actually give you the root shell, which is super good. So let's test that, because we're going to use this flag to test other machines. So there's another machine that I have called, well, I have a whole bunch of other machines. Let's use my photos machine. This is just another machine I have called photos. I can SSH into it and there's nothing here. That's super nice. Let's SCP the exploit over to photos. So we're sending the compiled binary EXP over to that photos program. Oh, interesting. I don't think I've updated the SFTP subsystem. I'll have to look into that later. This is, that's really interesting. It should be, if I do SCP-cap-O, it works. I might cut this out of the video, but I might leave it in. People like the debugging as part of the video, so I'm gonna have to leave this in. All right, let's see. SCP has a -cap-O flag that I've used before. Use the legacy SCP protocol for file transfers instead of the SFTP protocol. I don't know why I'm getting myself into this situation. It could be because of my SSHD config. So let me cat that and then decide if I want to leave it in the video. This looks fine. There's nothing to really hide here. I have gateway ports on. That's interesting. This should be... What's wrong with this? Yeah. It should work. I don't know why I have to use the -O there. Oh, look at this. I log into the photos machine and it doesn't have that option at the bottom. It doesn't have this subsystem SFTP line. I must have added that at some point in my configuration management software. I'm going to give you guys a spoiler. This is some configuration management software I wrote in Bash. I wrote it over 10 years ago. I called it Basher. There has now since been new software named Basher. So if I were to release this to the world, I would change the name. I'm just letting you guys know there, so don't get attached to this name. But let me go ahead and run Basher, and this will reconfigure a whole bunch of stuff on my machine. Wow, okay, so there's been a lot of stuff that has changed there. Look at this commit. Add subsystem for SFTP. It's been over a year, and I haven't pushed this out. Ugh, that's my fault. I'm installing Node.js LTS. I just install Node on all these systems? Interesting. That's interesting. Can I xpps install -s v Node.js LTS? I shouldn't even have to install Node on all these machines. Now it seems, well, no, we have to update the cache. Okay. Huh, these are really weird errors. I think it's because I'm using a mirror in front of the void repositories. Let me double check something, because the void machine I have works. So now we're logged into the void machine. If I etsy, what is it, xpps.d 00 repository, it puts it here, because that's my internal name. So let's SSH into photos. And then let's cat etsy xpps that. And it's the same thing. They're both /current. They're both exactly the same. It seems like that should work. What is happening here? Let's just try and install and see if this fixes anything, or an update. There's probably not too much to update. I did an update, I'm trying to think, I did an update for the last video, so that would have just been a couple days ago. I can't imagine this fixes much, but sometimes this just fixes weird errors, so let's let that go. Also here, you know, while it's running, I could, that's a small terminal. I can go here, I can SSH into cache, and then I can run this tail command, tail -capf, which will follow after any sort of like weird truncation or moving of the files. Application *proxy. And this will show all my proxies. So you can see that the xbps proxy is doing a lot of stuff. And it will say like, oh, I have an incoming request for this. Let's proxy the GET request here and let's save it to a local file here. So that's how that cache server works. It's a server I wrote probably over 10 years ago now in Node.js. I guess I'll put the link in the source code if people want it. Can't promise there's no bugs with it, but it's only accessible internal to my network. So that's kind of how it works. So it's nice. It'll pull down this like file, and then when something else comes and tries to pull it, that file will exist. And I think I have like a cron job set up to clean it up after some amount of days. Probably. I probably have that set up. You know, I realize I'm doing all of this. I'm upgrading all of the software just so I can run that command to put one line at the bottom of the SSHD config. So yeah, if you've ever seen, what is it? This is just how technical debt piles up. It's like, oh, I can't do this until this works. I can't do this until this works. I can't do this. And then you start to pop off of that new data structure that I just invented, where you put a new task on, you put a new task on, and then you pop that one off, you pop that one off. It's a brand new data structure I just invented. We'll have to come up with a name for it. Probably Dave structure, I'm thinking. This is so dumb. I probably just cut that from the video. I'm gonna grab a drink. This is gonna take a while. I wonder if other machines are gonna have this issue. I should probably test that. So if I SSH back into void, dev, what was it called? Dirty Frag. Let's SCP the exploit over to another machine that's running void that I can test. Vulture is one that I know the name of. It's gonna have the same bug. That's so interesting. Let's SSH into Vulture. And let's try to do that sudo run basher, and let's see if it breaks on Node.js LTS. I'm willing to bet it will. Yeah, okay. Wow, how fun. Oh man, it was like over 10 years ago now when I wrote a lot of Node, and a lot of my tooling on the server was written in Node. And I've since migrated a lot of that away. Like it's all bash scripts, compiled C programs, or compiled Rust. So I'd have to look into that. I probably can get rid of the Node.js dependency. I don't even know if I'm using it anywhere. That would probably be nice, but I should get to the bottom of what's going on here. All right, let's test all the machines while we're still waiting for that update to go off. Opt custom etc distro void. There are all my void machines. We can do sshp into that file, and let's run tail -1, so we'll get the last line of the sshd underbar config on all those machines. Okay, so we can see that void is set up, has is set up, sifs is set up, and plex is set up, but notch, WireGuard, VJ, photos, and vulture. So I got very unlucky when I chose photos and vulture randomly. Interesting, this one has gateway ports and this one has X11. I must have added those two separately. Interesting, how fun. We'll see how long this upgrade takes. If we can resolve the issue, that's great. I still might go through and just put this line at the bottom of the files and restart the SSH servers on them just to make our lives easier, or not even touch them at all, because I can still run SCP minus cap O and it works just fine. I'm just creating extra work for myself, but you guys say you like the debugging, so here you go. This is really what it looks like when you manage these systems like me, and I apparently haven't upgraded this in like over a year, so that's super fun. Honestly, I should just tear down these virtual machines and just recreate them and test to make sure that workflow works. If you have a workflow that you think works and you've only ever documented it but not tested it, you don't have a workflow that works. Do as I say, not as I do. Oh my god, huge update. I was scrolling on my phone, look at this. I'm pointing to my screen. Look at this, Node.js 24.14. Okay, so now it downloads. We'll see what happens here. Yeah, we'll see what happens when this goes off. I just happened to look up and see it. That's so funny. Okay, so the update went through. Let's go ahead and see if this works now. So if I do the run basher command, we'll see what happens this time. Maybe the update just magically fixed everything. The update magically fixed everything. Sure. Awesome. Love it. Love to see it. That's super great. So that should have updated the SSHD config. I'll scroll up. As you can see, there's a lot of stuff going on here, a lot of files. I have managed through it. I will make a video eventually going through my whole home network and how all this stuff works. I will clean up this code. I will open source it, because all this output you're seeing is from a tool that I wrote, and there's a lot that goes into it. But look at this. This is what we wanted to see. It added this line to the code, or to the SSHD config. You can see it was written here. This is the difference. And then we restarted the service. So the service should have this new config now. That's awesome. Great. So now we just need to go through and update all of the machines. So that's actually not as bad as it sounds, because we've used tooling in the previous video to do this. We've already done this in the previous video. We use the sshp command. So sshp-f op custom etc distro void. This will do ourselves. It's not a big deal. This will also do photos again. Not a big deal. We can do a couple different things. We could run like 3 at a time. We could group the output. We could do all sorts of things, but I figure the easiest thing is just to blast them all out at once. No, actually, now that I think about it, for the sake of this video, here's what I'm gonna do. Let's group the output together, and let's do an M1. This will do 1 at a time. I'll show you what that looks like. If I were to run uname across all of them, you will get this. So it'll do one at a time, and it puts the output down here. That's because it won't repeat the host name for every single line of output. It will repeat the host name only if a new host is emitting data. So if we were doing 2 or 3 at once, they'd be fighting each other, but here it's going to be just fine. So we can do xbps install dash capital S YVU. So S to synchronize with the upstream, Y to assume yes, V for verbose, and U to update. And then we'll just throw in a sudo. So I'll show you what happens if we don't do it. It'll just complain. All of them will complain. And yeah, it's just going to complain because of permission denied. So let's go ahead and let's toss a nice sudo in front of this. And we'll also give it a -E argument to SSHP. That will show the exit code when it's done. So we'll be able to see if it was successful or not. So let's run this and let's just let this go. So the first machine it's doing is sifs. As you can see, it's going through. It's doing all these updates. These will download way, 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 way faster because they're cached locally. If we go over to the cache, you can see that, well, you can't actually see those being hit a lot because now it's already done pulling the cache file. So we're kind of fighting each other for output over here. I'll get it on the next one. So let's let this one go through. If it's green, it's standard out. If it's red, it's standard error. So red doesn't mean like it's errors or it's broken. It just means it's being emitted to standard error. That's how it's colored by default. So there we go, exited 0, that's awesome. Now we're doing HASS, H-A-S-S. So if I go over here, you can see that the cache is going wild, which is just dishing out files locally, which is super fine. I'm gonna go ahead and just close the cache. We don't need it anymore. Let's just let that thing go. Let's go back over to this pane, and this one's gonna go through each host one by one, and we will just let the updates kind of go at their own pace. Again, if I were doing this not as a video, I might just do a bunch at the same time and not super worry about it. In fact, I might even hide the output and just show the exit codes. I think SSHP, I'd have to double check, maybe it takes a -Q argument, because I don't even care really what the output is. I just care if they were successful or not, and if like 2 failed, I would just log into those 2 and figure out exactly why they failed. So yeah, like I said, I'll let this run, and we'll come back to it when they're all freshly updated. And then once that's done, we can go through and we can do that run basher command on all of them, and that will update the SSHD config along with some other things for each machine. So we'll let this run, I'll cut the video, and when I come back, it should be all good to go. Cool, and it's done. And the cool thing is the whole SSHP command was successful, so that means every single host was successful in going through the upgrade. This is the beauty of doing a rolling release operating system like Void. Sometimes you just gotta do a full upgrade and it kind of just fixes things. It also breaks things, but it can also fix things. So that's super fun. If I were working at a company or something, we would be doing things way differently. I wouldn't be using rolling release, or I'd be locked to specific packages, some sort of long-term support. I would know way more about the system. But for here, these are virtual machines that aren't accessible to the internet. So we have some fun here. Well, they can access the internet. What I mean is they can't be accessed from the internet. Although I guess the WireGuard one technically can. Well, that's something to think about. So back on track. Now that we have that done, we can go through and we can rerun that run basher command across all the machines. And that will make sure that they all have the latest and greatest in SSHD configuration technology. So this will be significantly faster. We still could do the run one at a time type thing. What I'm going to do instead is let's mess around here. Let's look at some of the options. I put a -H there so I can see the SSHP options. I believe there is a -Q for quiet. Oh, nope. Good thing I checked. S for silent. There we go. So let's go ahead and let's do -SE. So we'll have the exit codes and they will be silent, and we will run 10 at a time. There's less than 10 machines to run this on, so it's just going to blast and do all of them at the same time. Cool. So 2 of them failed immediately. We'll look into that. Could be a simple SSH agent error. Could be some transient errors. But a lot of those were successful. That's awesome. So photos and HASS failed. So let's go to photos, do a run basher. I anticipate this will just work. Something probably just failed to sign. So the other one was HASS, I believe. So let's double check that. Do a nice little run basher here. And we'll see what happens. Okay. So yeah, it actually had to pull some data. I had to do some work here. Okay, it's doing work. That is beautiful. Awesome. Cool. So now this should be good to go. Let's pan over to the other terminal that I still have open. Remember how we checked the last line of the SSHD config? Let's do that again. One of them wants to, the authenticity of that host must be a new host. Interesting. So I'll just type yes, which will permanently add it. Cool. Let's rerun that. And let's take a look at this. Oh, we're getting that agent failing to sign thing. So a bunch of you guys had some theories on what was happening in the last video this happened. This is a bug with the program I'm using to do my SSH agent on my Mac. It's called Secretive. There's already an open issue for it. The author says that he's taking a look at it. I added my own comment on it, basically just pasting my own issue saying like, hey, I can also see this too. Here's my version numbers, etc. So it's transient. It's not great. If I rerun it, look at that. They all have SFTP server. So how was that for a debugging tangent? Because all that lets us do now is SCP files without the -O. How awesome. So let's go into Dirty Frag right here and let's SCP that exploit over to photos like this without the -O. And it works. All of that to make that work. How fun. So let's go over to photos now. And this machine should be exploitable. So if we run the EXP program here, it was compiled on one machine, but it's going to run the other. They should be fine. They're both the exact same version of Linux. There shouldn't be any issues here. So we run this and we should get a root shell. Awesome. We have a root shell. I mean, not awesome, but kind of awesome. You know what I mean? Let's back out of this. We can run the flag that we had before, which was what? Corrupt only. So take a look at this. I like this because watch what happens here. Wait, that's not right. It shouldn't return a root shell. It should just corrupt the binary. Did I misspell something? Is that spelled wrong? Hold on. EXPC corrupt -- corrupt only. Dirty Frag corrupt only equals 1 envar. Interesting. Yeah, wait, I swear I typed this right? This should just return. This should just return immediately instead of actually giving me the root shell. Hold on. What am I doing wrong here? Did I spell that right? I think I did. That looks like it's spelled correctly. It shouldn't give me the root shell here. Is it because, let me think. Is it because I already ran the exploit once? That shouldn't make sense. Let's test one other machine just to make sure. It's really interesting. Let's verbose this and see what's happening here. I don't know if this will be useful, but we'll take a look and see what's going on here. All right, well, that's not doing exactly what I thought it would do. So let's do some programming here. We're just adding some debug lines here, and then we'll see what happens, basically. So if we CC that, and then we run the exploit here. Oh, it's going to fail on this machine because I've already put the fix on this machine. Here's what we're going to do. I'm on the void machine. Let's go ahead and get rid of the fix. We're actually going to make this machine susceptible to the bug again. Not great, but we can get rid of this dirty frag thing here. I need to be root to do that. There we go. Reboot the machine. This will reload the kernel modules and it will be susceptible again. That way it'll just make it easy to test on this machine. So not exactly what you'd want to do, but we're going to go ahead and make this machine exploitable so we can mess with it. All right, let's go back in that directory, run the exploit -- corrupt only, and let's see what happens here. Interesting. Okay, didn't print anything, so let's take a look and see what's happening here. Where was that verbose flag being set? We just had a variable called verbose equal to 1. Oh, we silenced standard error. Interesting. Wow. You actually just dupe over standard error if it's not verbose. That's what I thought. That was my hunch, is that without verbose, we're not going to see those printfs show up. So that's what's happening there. Interesting. Is this just not read anywhere? Where is this? What is this? SULPE main? Co-argv. Okay, so we have new argc. Okay, so we're not copying over things. I probably should have looked at the source code more before I mess with this. Append corrupt only. What? Okay, I see what's going on here. We have like small little programs like this version of main if it's using the RxRPC one. If you're doing the ESP one, you're using this version of main, SU_LPE main, and they're getting a different version of argv and argc, but that is fine because they're appending the corrupt only flag, so they always get run with that one. That's very interesting. Then we call run root pty. It looks like this might just run no matter what, so that's probably not what we want. On the corrupt only arg, so the chain wrapper can skip the end process SUPTY stage and exec SU itself. Okay, I may have misunderstood then what this flag did. I think I may have ascribed meaning to it that was not what it does. So if we scroll up, what function are we actually in? We are in this. So that just returns out here, and then we get the return code of it. Okay. And if it's not already patched, then we try again. Okay. I see. But then down here, we run the root PTY no matter what. So let's do something else. How about this? You guys ready for this? How about this? There we go. So instead of running the root PTY, we'll just print that it was successful. Okay, so we've just overridden the source code there ourselves. Let's run that ourselves and see what happens. So it should work. We should not get a root shell. I might still have to give it the corrupt only. I'll have to double check that. There we go. Dirty frag success, exploitable. Okay, now this binary will be really useful for letting us know if we are exploitable or if we're not exploitable. That means we should be able to run our fix script. I know it's been a while, but here is our fix script here. If we run sudo./fix, now we have to reboot the machine, so let's go ahead and reboot. If we rerun the exploit, it should give us an error code basically saying that it's not exploitable, if it all works how we expect it to work. All right, we're back in the machine. We got an uptime of 0 minutes. That's perfect. Let's go back into our dirty frag and let's run our exploit again. And look at that, it failed. So now we have a way of determining if our system is exploitable or not exploitable. So let's go ahead and get this file onto all of our machines, because if we were to send this over to, photos, now we can SSH into photos, and we can actually just run ./exp on that remote machine, and then we will see if it's exploitable or not exploitable without actually having to spawn an interactive shell. It's taken a long time, probably a good chance it's exploitable. So there we go. That's awesome. Now we can use SSHP to go ahead and run that across all machines. Here's the fun part. We need to get that file onto all machines. So we need to SCP-EXP to every single host that I have. I'm going to show you a cool little way to do that. Super simple, but I figured this will be useful for you guys if you're ever in a situation, like if you're ever in a situation where you need to be able to do this. I have some tooling that lets me do this, but I figured it'd be cool to show you kind of how to do it manually. So here's my host list. Here are the list of all the hosts I need to send that file over to. That also includes ourselves. So we could write this out. We could just use this file exactly. We could just do something like this. While read -r host is a variable, do echo $host, done, and then we can read in from that file, and then we have a nice one-liner that lets us loop over line by line and do something. So now that we echo host, we can also SCP that file to that host :temp.exp. That's the name of the file that we'll write it to. I know this is a little bit hard to read, but we're going through host by host and SCPing it there. What I'll do for the sake of this video is we will make a new script called copy exploit to all. And this script will go ahead and do exactly what we did in the one-liner, but I'll break down the one-liner here so you can kind of see what's going on here. So let's go here. Let's do this. Let's do this. Again, exact same thing, unminified for you guys. So this is all we're doing. We're looping over the hosts that are in this file one by one. We print the name of the host, and then we SCP it over to /temp/exp. So if we were to chmod copy exploit to all and run that, it just goes through and it copies the file to all the machines. We can prove that by picking a random machine, let's say WireGuard, and then we can run temp.exp, and this will run the exploit, and it will let us know if it was successful or not. It's taken a long time. It's probably going to be successful, and it should be how it's expected to be. But now we have all those machines. We have that script copied over all the machines. We can go ahead and run the exploit on all the machines. We have that SSHP command that we know will work here. So same deal. We can just give it the opt custom etc distro void. I'm very verbose in my file naming. And we will just -t to trim off the arguments. It just makes it nicer to look at. And then we can run temp.exp. There we go. So we got a failure on Vultr. Again, I have issues with my SSH agent when there's a lot of requests going out at once. So you can see that it failed on Void. That makes sense. And the rest of them were success. We can assume Vultr was also a success here. Here's the other thing, because I know some of you guys don't have SSHP installed. I'm going to show you how to do this manually. So just like we have copy exploit to all, we can make something called run command on all. There we go. So we can make our own script to loop over that list, and instead of running this, we could run SSH into that host and then run whatever command we gave it as the arguments. So obviously, this program's dangerous. Okay, guys, we're logging into all these machines and running a simple command. But I want to show you what this looks like. Also, I want to show you how this can fail because you've probably hit this bug and you've probably gotten annoyed by it. Let's do run command on all, and let's go ahead and run echo hello on every single host. It stopped. It only ran it on one host. Why did it stop? Why did SEP work, but SSH didn't? I'm going to show you the specific fix, and then I'm going to explain it generically. You ready for this? -n. SSH -n. There you go. That's the specific fix. That will fix the issue that you are seeing right there, and if you take nothing away from this video, take that away. I'm going to explain why, though, because this is super annoying, and I've seen a lot of people hit this, and I've had a lot of people ask me about it. -n redirects standard in from dev null. Actually, prevents reading from standard in. SSH can read from standard input. Do you know why that's a problem? It's a problem because our while read loop over here is reading standard input. So this read command runs, it gets the first host from that file. This command eats up all the standard in. There's nothing left to loop. That's what's going on here. So you might have other commands besides SSH that don't take a -n flag. You can simply do this. Read in from dev null. This prevents SSH from reading in or consuming our standard input. It'll still try to read standard in. It's just there's dev null. There's nothing there to read. So if you have a weird command you suspect is the problem, toss this at the end of it in your while loop and it will work. So if I run that again, there you go. Now we're SSHing into all machines one by one and we're checking it out. So with that, we can go ahead and run something like uname across all the machines. Hey, that's super nice. In fact, if we wanted to, we could say echo -n host with a colon and a space here. So then when we run that, we could do this, and look at that. The output is a lot nicer. Obviously, SSHP is the command I like. It's way faster. It does parallelization, all that cool stuff. But if you're on machines that don't have that, you're logging into some weird systems, here's a simple script, like, you could make this a one-liner to do what I'm doing here. All right. So for the final thing, we can run command on all. The command we're going to run is temp exp, and we can see if they're exploitable or not. Obviously, we already did this with SSHP. We already know it's going to work. That's why SSHP is great, because it does them in parallel. When you don't do them in parallel and it takes like 10 seconds or whatever it takes here to run, this will take a while. This is super annoying, but hey, it works. We can run a command on it without having to compile that C program. SSHP is what I'm talking about here. So let's control C out of this, and let's figure out what are we to do now, because we have the exploit on all machines, but we need the fix. We need this script to run on all the machines. So we have that copy exploit all script. We could change this to copy file to all. So let's open up that file. Now we have this script called copy file to all. Well, let's say the file that we want to copy over there is our first argument, and the destination. So let's do this actually. Source and destination will be the second argument. We can use this syntax. I really like this syntax. This will error if those are unset. So it'll kind of force us to have to put those in, but we're not giving super nice errors. This is just meant for quick and dirty scripts for us. So we will echo the name of the host, and then we'll SCP the source to the destination. There we go. So now we can echo the host, and we could say source to dest. There we go. So now if we run copy file to all, we can copy the fix over to /temp fix, and this will put it on temp fix on all those machines. So you can see that's what's happening here. We're SCPing it to all those machines, and that's the fix right there. So now if we were to run command on all we'd have to do is run temp fix. This will fail. We don't have root, but I'll show you this anyways. You can see that we get a bunch of permission denied. So we're going to do an extremely dangerous thing. Be careful, double check, triple check, quadruple check your work. Sudo temp fix, and this will run the fix on all of them. Again, there's still going to be some error messages because those things haven't exactly been loaded. So there you go. That's awesome. The final thing we need to do is we need to issue a reboot on all machines. Because we're on one of the machines that's going to SSH on all these machines, you got to be a little more careful because of ordering and stuff right here. So there's a couple things we can do. This is where you could just like change the command if you want to. I'm going to use the SSHP command because we've actually used this in the previous video. What I can do here is I can grep for anything that doesn't start with the word void, which is our current host. and I can grep that out of opt custom Etsy distro void. So there's our new list with our own host name taken away from it. Pipe that into SSHP. SSHP will read from standard in by default. Now I can run a command on all those machines. So we would just run reboot across all those machines. This will fail because you need to be sudo to do it. Let's go ahead and do a -M1. We'll just do one at a time, easier to see, and we're less likely to hit that race condition with signing the agent. Let's go ahead and rerun that with a sudo. So we'll reboot all those machines, and there you go. All these machines will be going down for a reboot so they can pick up the changes. Then, now that all that went through, we just run sudo reboot on ourself, and we will wait for it to come back up, and then we will check things out. Cool, so the machine is back up. I just realized this because I put the exploit in temp. Again, it's gonna be wiped out from that reboot. So first let's check the exploit locally. Look at that, it failed. That's amazing, that's good, that's what we want. Let's go ahead and copy the exploit to all machines. So every machine will get the exploit in their temp directory. And then we will do the final thing, which is run command on all machines, and we will run temp exp, the exploit. So on all machines, we're gonna check it out, and look at this. It fails. It fails on all machines. That's good. That is what we want. That's beautiful. The machines are no longer susceptible to that exploit. They have been patched for dirty frag. So yeah, a lot of stuff went into making that happen. A lot of fun issues along the way. Hopefully you guys enjoy the debugging that went with it. And hopefully you enjoyed me manually unrolling some of these commands I do and show that, like, yeah, you can still write these commands. Like, even if you don't have SSHP, a quick 4-liner bash script, like, look at this. Run command on all, it takes a list of hosts and it runs a command on every single host. You could write this in a couple lines of bash. You could write this as a one-liner. I can write this off the top of my head. This is good stuff to know how to do. Obviously, I like my tooling better. It's faster, it's parallel, it does a whole bunch of stuff for you. But that tooling has come from, you know, like years and years of working in the industry. And shout out to one of my previous coworkers for writing one of the like original versions that I used. This was over 10 years ago. Yeah, he was awesome. So yeah, this is how I would fix the exploit. And this is not a hypothetical. This is just actually how I fix the exploit. You guys watch me fix it in real time. That's how it's done. That's how I do it. So yeah, there we go. These machines have been patched. They are no longer vulnerable to that. I can't wait to see you guys again in a couple days when the new 0-day Linux vulnerability drops. I'm so glad to be unemployed and not working on back-end systems where I have to go through and deal with all the upgrades and stuff from it. So yeah, there we go. That's all I got here. Of course, I got to give a shout out to my patrons over at Patreon. So as you can see, there are a lot of you guys now. The output has slightly changed. There is going to be new output to this that does beautiful scrolling and it looks so much nicer, and we put a whole bunch of work into it. I did that during a live stream and I cut that up, and I'm going to make a fun video, and I was going to post that video next. But this exploit dropped, so I had to make a video for this exploit first because I had to go patch my systems literally the day it came out. So this is the last time you'll be seeing this output where I'm manually scrolling it with my finger on the mouse right now that you guys can't see. The next time you watch this Patreon output is going to look so much nicer. So yeah, if you want to sign up for my Patreon and give me money and get your name at the end of my videos, go sign up down there. Take a look at that. 113 active members. I have 101,000 subscribers on YouTube at the time of recording. So go ahead, hit that subscribe button, do whatever you got to do. Like the video, share it, and let me know, most importantly, I guess, let me know how you like these videos. Do you like the behind the scenes? Are you excited to see some of my tooling for configuration management? Because I keep just randomly dropping lore on you guys with like different tools I've written. So it's a lot of fun. Let me know what you guys think in the comments. And yeah, that's it from me. See you, everyone.